creation of this video is completely out of passion. We have discussed here 7 points which are explained very briefly to the point. During the creation of this video, it is being realized that the scope and duration of this video is too small to explain a subject matter like time. But as we have titled the video Simple Explanation of Time, we tried our best endeavor to keep it like that. Hope you enjoy. Let us start with the introduction of time. We all are familiar with time, yet it is hard to define and understand. Different schools of thoughts, such as science, philosophy, express time differently. The school of faith and the arts have different definitions of time in consist of their each dogma. Fortunately, the system of measuring it is relatively consistent. Through the passage of history, the basis for these units has changed. They trace their roots back to ancient Sumeria. Time measurements are based on seconds, minutes, and hours. The modern international unit of time, the second, is defined by the electronic transition of cesium atom counted in the atomic clock. Having all this practical working evidence, but what exactly is time? If we see the scientific definition of time, it is the progression of events from the past to the present into the future is how the physicist has defined time. Basically, if a system is unchanging, it is timeless. Time can be considered to be the fourth dimension of reality used to describe events in three-dimensional space, where all other three dimensions change due to progression of time. Time is not something we can see, touch, or taste, but we can measure its passage. Let us see what is the arrow of time. Physics equations works equally well whether time is moving forward into the future, known as positive time, or backward into the past, known as negative time. However, time in our natural world has one direction, called the arrow of time. The question of why time is irreversible is one of the biggest unresolved questions in science. The most popular explanation is that the natural world follows the laws of thermodynamics, as in the second law of thermodynamics states that within a closed system, the entropy of the system constant or increases. As per Big Bang theory, the universe is constantly increasing with time. So if the universe is considered to be a closed system, its entropy, that is the degree of disorder, can never decrease. In other words, the universe cannot return to exactly the same state in which it was at an earlier point, as the universe is expanding, and this expansion is happening at an accelerated rate. So, time cannot move backward. A better understanding of entropy and the second law of thermodynamics could have made the above explanation more clear. However, the detailed explanation of what is entropy and what is the second law of thermodynamics demand for a separate video of their own. Let us check now what is time dilation and how it works. In classical mechanics, time is same everywhere. Synchronized clocks remain in agreement. To understand more clearly the time dilation, a good knowledge of physics will be an added advantage. As per the law of Einstein's spatial and general relativity, that time is relative. It depends on the frame of reference of an observer. For an example, if two persons, let's say a boy and a girl, of same age were part of an experiment where the girl goes into a rocket that blasts off 99.99999% speed of light, and the boy stays on Earth. These boy and girl would experience time in very different ways. 80 years later, the boy on the Earth will be an old man, and the girl in the rocket would have only aged one day. Time slows down or speeds up depending on how fast one moves relative to something else. This can result in time dilation, where the time between events becomes longer or dilated the closer one travels to the speed of light. Moving clocks run more slowly than stationary clocks, with the effect becoming more pronounced as the moving clock approaches light speed. Other example can be cited as clocks in jets record time more slowly than those on Earth. Also, muon particles decay more slowly when falling. And last but not least, the Milson-Morley experiment confirmed length contraction and time dilation. Let us talk now about what is time travel. Is it possible? Jumping forward in time occurs in nature. Time travel means moving forward or backward to different points in time, much like we might move between different points in space. Astronauts on the International Space Station jump forward in time when they return to Earth because of its slower movement relative to the station. As we have already discussed, time slows down or speeds up depending on how fast one moves relative to something else. The idea of time traveling back in time, however, poses problems. One issue is causality or cause and effect. Moving back in time could cause a temporal paradox. The grandfather paradox is a classical example. According to the paradox, if you travel back in time and kill your grandfather before your mother or father was born, you could prevent your own birth. Many physicists believe time travel to the past is impossible. But there are solutions to a temporal paradox, such as traveling between parallel universes or branch points. A detailed video on time travel has its own appeal. We will discuss now the time perception as human species. Humans have a fitful relationship with the clock. If modern idioms are any indication, time flies when we are having fun. It drags when we are bored. Sometimes it is on our side, other times it is racing against us. The human brain is equipped with track time. The suprachiasmatic nucleus of the brain is the region responsible for daily or circadian rhythms. But neurotransmitter and drugs affect the perceptions. Chemicals that excite neurons so they fire more quickly than normal speed up the time. Well, decreased neuron firing slows down the time perception. Basically, when time seems to speed up, the brain distinguishes more events within an interval. In this respect, time truly does seems to fly when one is having fun. However, time seems to slow down during sense of fear and danger. Scientists at Baylor College of Medicine in Houston say the brain does not actually speed up, but the amygdala becomes more active. The amygdala is the region of the brain that makes memories. As more memories form, time seems drawn out. The same phenomena explains why older people seem to perceive time as moving faster than when they were younger. Over time, the rate at which we process visual information slows down in old age, and this is what makes time speeds up as we grow older. Since fewer new memories are built later in life, time seems to pass more quickly. Let us talk the beginning and the end of the time. As far as the universe is concerned, time had a beginning. The starting point was 13.799 billion years ago when the Big Bang occurred. We can measure cosmic background radiation as microwaves from the Big Bang. But there isn't any radiation with earlier origins. One argument for the origin of time is that if it extended backward infinitely, the night sky would be filled with light from older stars. Will time end then? The answer to this question is unknown. If the universe expands forever, time would continue. If a new Big Bang occurs, our timeline would end and a new one would begin. In particle physics experiments, random particles arise from a vacuum, so it doesn't seem likely the universe would become static or timeless. Only time will tell. Let us conclude with the key points now. Time is the progression of events from the past into the future. Time moves only in one direction. It is possible to move forward in time, but not backward. If we disagree the parallel universe concept, scientists believe memory formation is the basis for human perception of time. Thank you for your patience and time. For any queries, send email to rhkstore@gmail.com or write in comment section. Please subscribe, give a thumbs up, do share, and do not forget to press the bell icon. Thank you for watching the tutorial. Stay home and stay safe.